Question 11.55, determine the amount of heat required to convert 65.25 grams of solid calcium at 651 degrees Celsius into liquid calcium at 951 degrees C, given that the melting point occurs at 851. So we have to go 100 degrees beyond the melting point. I've provided the specific heat of the solid, the liquid, and then the delta H of the fusion process and the vaporization process. But we won't need this last one. We won't need the heat of vaporization because that's the energy required to go from the liquid phase into the gas phase, and we are not vaporizing that sample. We end at a liquid at 951 degrees Celsius. So taking a look at the calculations that we have to do, I'm starting off with solid calcium at 651 degrees Celsius. I need to heat that up to the melting point. So I need to heat it up to 851 degrees Celsius. And for that, I'll need Q equals mc delta T. The second calculation, now I have solid calcium at its melting point. I need to go through the phase change. I need to take that to liquid calcium at the melting point, and that's our phase change. And for that, I'll need Q equals how many moles of calcium do I have times the heat of fusion for calcium. Finally, now I have liquid calcium at 851. I need to take liquid calcium at 851 degrees Celsius and warm that up to 951 degrees Celsius. And now I'm going to be back to Q equals mc delta T, except for this time I'm going to use the specific heat of the liquid calcium and not the solid calcium that I used in step 1. So step 1, I've got calcium at 651 degrees. So Q equals my mass of calcium, 65.5 grams of calcium. The specific heat of solid calcium is 0.65 joules grams times degrees Celsius. And my temperature change is 651 to 851. My temperature change is 200 degrees Celsius. So my energy for warming up the solid calcium from 651 degrees Celsius to 851 degrees Celsius is approximately 8,482.5 joules. Step 2, well, I can find out how many moles of calcium I have, right? Moles equals grams over molecular weight. So I have 65.25 grams of calcium. And I know that for every 1 mole of calcium, I would need to have 40.78 grams of calcium for approximately 1.63 moles of calcium. So Q equals a number of moles, 1.63 moles of calcium times the heat of fusion for calcium, which is 9.33 kJ per mole. So this step will require approximately 15.22 kilojoules of energy. Now I've gone through the phase change. Now I have liquid calcium. Now I need to take that liquid calcium from 850 all the way up to 950. So one more 100 degree temperature change. My mass is still 65.25 grams. Now I want to use the specific heat of liquid calcium, which is 0.77 joules degrees Celsius, times my temperature change, 100 degrees Celsius. The energy required for the third step is approximately 5,024.25 joules. So now I have the energy of all 3 steps. The one thing you should notice is that I have 2 different units of energy. I have joules for step 1 and 3, and I have kilojoules for step 2. Taking a look at the question, we want to determine the amount of heat required in kilojoules for this process. So step 1 was 8,482.5 joules, and I know that there are 1,000 joules in 1 kilojoule, so that brings me to 8.483 kilojoules. Step 2 was already in kilojoules, that was 15.22 kilojoules, and step 3 was 5,024.25 joules. Again, divide by 1,000 to go from joules into kilojoules to determine that step 2 was approximately 5.024 kilojoules. Add all 3 of those steps together to get the overall process of approximately 28.73 kilojoules of energy would be required to take solid calcium at 651 degrees Celsius, go through the phase change, make it liquid calcium at 851, and then heat that liquid calcium from 851 to 951. Again, we had 3 separate steps because we had steps looking at just a phase change. We had steps looking at warming a solid, warming a liquid, and the energy for those 2 steps. Even though we're warming something up, the energy of each of those steps is a little bit different because the specific heat of a solid is different than the specific heat of a liquid.